practice with similar solids today, and I wanted this video to just give you one more example of how to solve. If you know, in this case, we know the volume ratio. So we know one of our ratios, and that's going to be step number 1 to use that to create the table. And then step number 2 is knowing the surface area of the smaller that we could find the surface area of the larger. So that's going to be step number 2. And basically, you could go back to the video from yesterday if you wanted to see at the end of the video an example of some not so nice numbers. And that's what we're doing here, an example with some not so nice numbers. So step number 1, let's go ahead and make our ratio table. And we want to find all 3 ratios here: similarity ratio, or you could think of this as the scale factor. We want our surface area ratio, which at its root is just an area ratio, and we want the volume ratio. Here, again, we know volume, 115 to 67. I'm going to go ahead and flip it and do smaller to larger. So smaller to larger, boom, just like this. And I know, because I have this, I know that I have a cubed and I know I have b cubed. And so how do I find the rest of these? Well, I have to work my way all the way back to just what a and b are. So I have to undo that cubing, like we saw earlier this week when we were working with volume of a sphere, by taking the cubed root. So I need the cubed root of 67 and 115. Now, first things first, actually, before I do this, let's check and make sure that this doesn't reduce to some nice number. Consequently, I did already check on my calculator and it does not reduce to a nice number. But again, you could save yourself a lot of headache if you check that and see if they come out to be a little nicer than what we're going to get when we take the cubed root here. So if I take the cubed root of 67, and you can try this in your calculator right now, not such a nice number. Same thing with the cubed root of 115. They're not nice numbers. I am going to just type this into my calculator, cubed root of 57, and I am going to store that as alpha A. And then I'm going to type the cubed root of 115, and I am going to store that as alpha B. I'm not really that interested in what the decimals are because, again, I don't want to use any intermediate rounding. So just as a reminder of how to get to this in your calculator, math button is the menu key essentially that you're using. And then the 4th option under math is the cubed root. And that's how you're going to get to that. So again, I'm going to take the cubed root of 67 and I'm just going to store that right away as alpha A. And then I'm doing the same thing for the cubed root of 115, but storing that as alpha B. Okay, those are in my calculator. And then in order to do my surface area ratio here, I would take the cubed root of 67 and I would square it. And I would get another not so nice number. And I would take the cubed root of 115 and I would square it. But again, I could write my decimals here, but really, even though this doesn't look much nicer, at least I didn't have to use any rounding. I know that those are my exact answers. So now that I have my ratio table, we're on to step 2. Step 2 is that we know the surface area of the smaller container is equal to 108 inches squared. And we want to know what is the surface area of the large. And so we're going to do our proportion here. Because we are talking surface areas, we are using our surface area ratio. Again, not a trick question here. You have to use the surface area ratio for this. So we're going to go ahead and do that. That's half of our proportion. You could write a squared over b squared. You could write the cubed root of 67 squared over the cubed root of 115 squared. However you want to do it, but I'm just going to remember that I have this in parentheses here stored as A, and this in parentheses here stored as B. So in my calculator, I can really use A squared and B squared. And then I know the surface area of the small, 108, and I don't know the surface area of the large. And so I'm going to do my cross multiplying here. Because I do have this stored as a squared, I'm going to go ahead and call that x times a squared, so I don't have to rewrite the cubed root of 67 here. And then on the other side of this multiplication, I have 108 times what I have stored here for b squared. So to solve for x, I'm going to divide out a squared from both sides. And then this right here on the left is what I'm plugging into my calculator right now using alpha y equals, oh gosh, let me write that a little better, using alpha and y equals as my shortcut menu to get to my fraction. I am typing 108 times alpha b squared in the numerator. I am typing alpha a squared in the denominator. Altogether, that one calculation in my calculator is giving me x equals 154.82. We were in inches squared, so that is inches squared. And keeping in mind, this is for the surface area of the larger, and just checking to make sure that that makes sense, that yes, that is a larger surface area than this right here. Makes sense. And hopefully, if we work out and we do all of our steps correctly, that we're getting the right answer. So just double check. Let me know if you have any questions, but make sure you're getting the same thing.